Hey there, the Network Berg here. Welcome back. This is the second video covering VLANs on MikroTik devices, specifically for the MTCRE. So we're looking at how to use VLANs as routing engineers so that we can extend certain services across the network and use VLANs for routing. Even though a lot of the stuff that I am showcasing is applicable to something that you might be able to set up in a switching environment, my main goal is for somebody to understand how to use VLANs for routing scenarios. Now, if you do want to look at understanding switching a lot better for MikroTik, I highly suggest you watch somebody called the Network Trip, I think. He's got great videos on MikroTik switching in general. Or I also suggest looking at the certification track for the MTCSWE, which is basically for the switching engineer, because that will introduce multiple different switching principles, and it will also teach you a lot about switching on MikroTik in general, how to add best practice scenarios. What I'm doing here is going to be a bit different from somebody wanting to learn how to use a MikroTik as a switch. All right, I just wanted to lay that out there. Now, let's get into the video. Alright, cool. So in this video, there's a few things we're going to go over. We're going to actually dive a bit deeper into VLAN theory, just so that we can get some better understanding about what we're trying to accomplish with VLANs. We're going to look at intra-VLAN routing, which is actually pretty straightforward. And in the previous video, we kind of had it working, but I didn't really showcase it. So we'll actually get that up and running. And then I also want to talk about something called QnQ, which is very, very cool stuff when it comes to setting up maybe special services or breaking up a link that was delivered as a VLAN to you, and then you want to separate some services like voice and data. QnQ works great for those type of scenarios. Now, what I've done is I've got an Eve topology here. We've got a provider edge, which is where we will be spanning some VLAN services to a CPE as to a customer. And then from the CPE, I've also got a bit of a switching scenario set up here where we're just going to go over some of the basics of VLANs. But I've prepared a little bit of a presentation, even though I don't generally like doing presentations because they feel like they might be a bit boring. And I typically speak from the heart and what's up here. So that might be why it seems like I make some mistakes sometimes, but it's because I typically speak off of what I've seen works, what I'm doing from experience, and I'm just talking from the heart generally. So let's just quickly do the presentation so that I can just cover the VLAN theory with you guys. So first things first, with VLANs, they are awesome. There's so much that you can do with VLANs on a routing and a switching layer. They are really bread and butter in the ISP industry. Now, VLANs operate at layer 2, which means on the OSI model, you're using VLANs to forward frames, and you're learning stuff like MAC addresses and seeing what a source MAC and destination MAC is. And it's just typically how data is being forwarded across an interface or on the switch. Now, on a switching layer, only devices in the same VLAN can communicate with each other. So that's actually quite useful because that adds a layer of security. If you put two devices in, let's say, VLAN 10, then the two devices in VLAN 10 connected to the same switch will be able to communicate directly. However, if you add, let's say, a VLAN 20 in your topology or in your network, then only the devices in VLAN 20 can communicate with each other. If you want these devices to talk with each other, then you're going to have to add something that we call, let's call it a layer 3 device, which is typically your router, or it might be a firewall, or it could even be a layer 3 switch, which operates at an IP level. It operates at layer 3, so it can route packets. And what this allows you to do is, if your VLANs terminate on the same layer 3 device, then you should be able to set up routing between these networks. Now, on MikroTik, it's actually pretty straightforward because the moment you add these VLANs under an interface, you've already kind of got the intra-VLAN routing set up. But then you can also do cool stuff like implement access control with firewall rules, which we'll cover in this video as well. Now, when working with VLANs, we are typically using the 802.1Q standard. So we've talked about it in the previous video, but all that means is it's an industry standard in how VLANs are typically configured. And I'm going to show you some examples in the slides as well, like what 802.1Q is actually doing. But it inserts a 4-byte header into the Ethernet frame. So it's basically, you get your Ethernet frame. It's like this long line thing with data and frame check sequences and ether types and preambles and all kinds of information in it. But what happens when you add VLAN tags to an interface and that frame leaves the interface, a VLAN tag is added on top of that frame to identify which VLAN the frame belongs to, which allows a switch to make decisions on which ports it's necessarily going to send out the frame, so that only devices in the same VLAN can ideally then get that information. We can configure up to 4095 additional VLANs ourselves, so that's usable VLANs that we can set up on an interface. So the 4095, it should actually be 4096, but the first VLAN that we get on a device, on a switch, when you take it out of the box, VLAN 1's already configured on it. It's just untagged on all of the ports, and this allows all of the devices to just instantaneously connect and communicate. VLANs are also very useful for service providers because it allows you to span a VLAN across a single backhaul. So let's say you've got one big fiber link or a wireless link to a tower. So you've got your data center somewhere, and you've got a wireless link to a tower from the data center. Like maybe you've got a few towers to get there. But what VLANing allows you to do is on that link, you can set up multiple different VLANs, because you don't necessarily want to have all of your IP information being set up on a tower or on a POP or whatever you want to call it. You might just want to span the VLAN across the network. So there's just layer 2 across the network, but between the DC and your endpoint, your CPE, you might then configure actual IP address details and routing and so that you can actually get between networks. Now, let's talk about something interesting. It's 802.1ad, which will informally or maybe even formally refer to as QnQ. Now, QnQ is another mechanism that works within 802.1q. So what QnQ allows you to do is you can create VLANs and tag it underneath a VLAN interface. So instead of tagging the VLAN to an interface, you're tagging it to a VLAN interface. So it's a VLAN under a VLAN. Think of it as a sub VLAN. The only downside of doing this is if you start adding QnQ for every sub VLAN. So let's say you've got VLAN 10 tagged under Ethernet 1 as an example. That will already add 4 bytes onto your frame. So that might already cause some MTU issues if you have some limitations. Now, the moment you start doing QnQ, it adds an additional 4-byte header. So it's like 4 bytes with 4 bytes. So it will be 8 bytes for the VLAN information for that switch to send across. Now, what's crazy is you can even add a VLAN under a sub VLAN under a actual VLAN, but then you're going to have even more overhead. So this is actually quite, I don't want to say rare, but you'll definitely use QnQ, but you need to be aware of your limitations, especially when it comes to MTU, because if there is a lot of overhead and the MTU just doesn't support it, then you're going to start having fragmented packets and you're going to start having some quality issues and some stuff doesn't open, and it's just a mess sometimes. But just adding a simple QnQ VLAN typically won't break the network, because MikroTik's or most vendors' new equipment almost like operates at almost 1600 MTU, like actual MTU. All right, and now MikroTik devices also allow you to set a service tag or S tag. Now, a service tag, it's not something you'll typically configure. However, maybe you are using some type of layer 2 provider to bring in links into your network. Then you want to configure QnQ, and you set up the QnQ on your data center environment, and you set up the QnQ at the endpoint at the CPE, because for the middle provider, the layer 2 provider, they don't necessarily see the QnQ stuff that you're actually doing. To them, they just care that you've got a frame going across the network. So they might have some proprietary systems that need a S tag option to be available. So if you then tick the S tag and you use QnQ, maybe before the QnQ didn't work, then it will potentially work if you just enable the S tag. All right, so this covers the basic theory of VLANs. Now I want to talk to you guys about the access port versus the trunk port. Now I've got the script here to say what an access port and trunk is, but essentially what I want you to understand is an access port is going to be the endpoint where a client or a machine or a server or a printer or something is connecting to a switch. So an access port is just going to be a VLAN list port almost. So you configure the access port in a specific VLAN, but the client doesn't even know about the VLAN. They don't set up the VLAN on their side. They just jack into the switch, and now they're actually part of the VLAN without knowing it, because the switch will know what VLAN that access port belongs to, and then it will just forward whatever frames within that same VLAN to other access ports, or even across a trunk interface. And now a trunk, I've also talked about it in the previous video, but that's more or less an uplink. So that might be connecting to a different switch. It might be connecting to a router. It might be connecting to a firewall, any myriad of devices. But what it's essentially doing is it's carrying multiple VLANs across it, so that, think of it as a trunk. It's just a big pipe with multiple VLANs. So the trunk's job is just to move VLANs between physical hardware. So here I've got a little bit of an example that I'll be going over. Sorry if my head is, let me just move my head there. So what I want you to see here with this picture is, this is a very typical network setup where you might have a router, and your router will connect to your switch, and then your switch is going to connect to some clients. Now, in terms of VLANing, what we could do is, between your router and your switch, you might set up a trunk port. So what happens in that case is you will create VLAN interfaces, put it under the Ethernet interface, or you could do it with some bridging or whatever as well. But the end goal is these VLANs, VLAN 10 and 20, will form under a single interface, which will be considered a trunk, and that will then connect to another trunk port on the other end, which is also allowing those same VLANs to cross over it. I wanted to say cross across it, but that sounds a bit funky. Then we've got our switch. So with our switch, we've got access ports configured. So Ether 2 is an access port for VLAN 10, and Ether 3 is an access port for VLAN 20. Now what this essentially does is any additional ports, so let's say I connected Ether 4 and I put that in access port mode for VLAN 20 as well, then the two devices in VLAN 20 would be able to communicate with each other. And on the same side, if I added a VLAN or Ether 5 and put it in VLAN 10 and had a client connect to that, then the devices in VLAN 10 would be able to connect. The switch would then be responsible for stopping the connectivity between the VLANs. But since we've got this trunk introduced, it also brings something where we get the inter-VLAN routing, where these VLANs will then go across their trunk, and then the router will then basically be allowing access to the other VLAN. So this is where you will hear the terminology router on a stick sometimes. All right, now I'd also just like to get into what Ethernet frames kind of look like, because the moment you take a switch out of a box, or when a layer 2, like a port, an interface works at layer 2, you've got an Ethernet frame, which has this preamble at the beginning, and these 1, 2, 3, 4, 5, this is the bytes that you see how big these sections are in a frame. So you've got your preamble, you've got a destination and source MAC address. So this is just an identifier to say where the frame came from and where the frame is going to go to. You've got an Ethernet type or size. You've got your payload, which is essentially the data that you're sending across. So think of that just as that information when you open the website and the picture load, like the payload is kind of like what's in the picture. And then you've got your CRC-FCS check sequence, or your frame check sequence, which just is making sure that the frame was delivered the right way. If there's some type of error, then it will just resend that frame. So think of this kind of like TCP, but just this is just going to make sure that there's no fragmentation. If there's a mismatch, then the frame will just get dropped, then it will have to be resent. All right, so this is just a standard Ether frame. So we haven't done any type of VLAN tagging. Now we're going to have an 8021Q frame. So this is where you've placed the VLAN under an interface. And now that interface is typically going to be a trunk, let's say. And now what happens is it's the same Ethernet frame, but all it's done is it's added this 802.1Q header inside of the frame. And what this essentially does is it will tell, firstly, it will tell the device that it is a VLAN header, that it's for VLANs, and then it will also tell you what the VLAN ID is. Now this VLAN ID needs to match on both sides in order for devices to communicate. And now let's look at what happens when you add a sub VLAN. So you add the VLAN interface under a VLAN interface, which is tagged on top of a physical interface. Now in this case, we've got the 802.1AD, which is QnQ. So you've got your frame, everything looks exactly the same, except now you've got multiple 802.1Q headers, which is now going to be where you've placed a VLAN inside of the VLAN. So you see this does increase the MTU size, so it increases it by 4 bytes the whole time. So again, if your MTU is too small, it's going to cause fragmentation issues that you just need to be aware of. All right, so this is going to end of the theory section, let's actually do some fun stuff and configure some things. So I've got my Eve topology open here. I've factory reset all of these devices. And the first thing that I want to do is I'm just going to configure this MikroTik switch, even though it's just a CHR. We're just going to set up some very basic VLANing on it so that we have different VLANs, and we'll put Ether 2 and 3 in access mode. And then we'll configure a trunk to our CPE1. So all I want to do is maximize here, maybe move my face back to its original position. And let's set up the switch. So in essence, all that I want to do is I want to go into my interface bridge. I want to add a new bridge. I'll give this the name as the switch bridge, SW-bridge. And I just want to enable VLAN filtering as well. So now we've got a switch bridge, and now we need to add our interfaces to the switch bridge. So I'm going to add Ether 1, 2, and 3, Ether 1 being a trunk interface. So I'll do interface bridge, add port, or interface bridge port, sorry, add. Our interface will be firstly Ether 1, which is our trunk. And what we will do is also just hardware offload this, and we'll set it for the switch bridge. I made it SR bridge for some reason, but let's just use that name convention because I've already got it set up. And I'm going to also just add interface bridge port. Let's add interface equals Ether, interface equals Ether 2. And then what we're going to do with Ether 2 is we're actually going to set a private VLAN ID for it. So we're going to say pvid, and we'll make this VLAN 10. And then we're also just going to set the hardware offload, and we're going to specify the bridge, which is this SR-bridge. And then lastly, we're going to go interface bridge port, add interface equals Ether 3, where Ether 3's pvid is 20, with hardware offload being yes, and our bridge is also going to be that SR-bridge. So now if I export the config, essentially what I've done is I've added Ether 1 as a trunk interface. I've added Ether 2 as a private ID or an access port for VLAN 10, and I've added also Ether 3 as an access port for VLAN 20. But this is not done yet. We still need to set the VLANs. So what we're going to do is interface bridge VLAN. So if I print this, we'll actually see there's already a VLAN table here telling us which VLANs are tagged, untagged, and all that good business. But we're just going to do a interface bridge VLAN add. Then we're going to set our VLAN ID is 10, which is VLAN 10. We're going to set our untagged as Ether 2, which is the access port. And we're going to set our tagged as Ether 1, which is going to be the interface responsible for carrying the traffic. And we also just need to specify our bridge as the SR-bridge. We're also going to set this for VLAN ID 20. And this is going to be untagged for Ether 3. I'm going to hit enter. And let's export this just to make sure the config is okay. So we can definitely see we've set our VLAN tags. And let's just print the VLAN table again. So we can see we've got the statically assigned IDs now. So VLAN 10 is tagged for Ether 1, which is the trunk port, and it's untagged for Ether 2, which is the access port. So we've got this switching set up now. So if we went and assigned stuff like IP addresses, or we added more hosts in these VLANs and added more access ports and put them in the right VLANs, then those hosts would be able to communicate with each other, but they wouldn't necessarily be able to talk to different VLANs. So for this, we're going to now set up the inter-VLAN routing. So what I'm going to do is I'll do this via Winbox, and then I'll just go into my downloads folder, use wine for Winbox, and this should open up a Winbox session for me. And then I'm just going to connect onto the CPE quickly. So here I've connected onto the CPE. Now let's just zoom in. And now let's configure some VLAN stuff here. So I'm going to go into my interfaces, and very basically what I'm going to do is my Ether 2 I know connects to the switch. I'm just going to connect or create a new VLAN interface. Let's call this VLAN 10, or let's call it LAN. Add it to VLAN ID 10, and my interface is Ether 2. And similarly, I'm just going to copy this maybe, call this voice, make it VLAN ID 20, apply that. Now this is a very basic way of how to just add tagged VLAN interfaces to a trunk, which will just be carried to the switch. But what I like about this is now I can just quickly add my IP addresses for each VLAN interface. So I will create maybe 192.168.0.1/24. Assign that to my LAN. And let's assign something like 172.16.0.1/25 to my voice. So now I've got IP addressing, and this will now allow these devices to have a default gateway that it can use to get to each other's networks. So all I'm going to do now is just quickly set up DHCP for both of those VLANs. And this is going to be straightforward, just adding DHCP servers. So I've got my LAN, let's add my voice. Now what I'm going to do is navigate back to Eve, go into my LAN PC. All I'm going to do is say IP DHCP. And it's got a DHCP offer received acknowledged. So it did receive an IP address from the CPE now. It has nothing to do with the switch. And can I ping my gateway 192.168.0.1? I can. And let's do the same for this phone and on the topology. So I'm going to give this IP DHCP. So it also just receives a DHCP address. And this is received 172.16.0.126. So let's see, can I ping my gateway 172.16.0.1? And that I can ping. But now our issue is, and it's not really an issue because the inter-VLAN routing is actually working. So from this phone, I'm going to ping the PC. So from the phone, I'm pinging 192.168.0.254. And I'm getting a response. Now, the reason that is happening is if I navigate back onto Winbox and I look at my routing table, both of those routes exist in the routing table as directly connected routes, and the router or the layer 3 device is in this case aware of how to get to them. So now I've allowed two VLANs to be able to connect to each other with intra-VLAN routing. But let me show you the nice perks of this, because maybe you don't want them to communicate with each other. That's totally fine. What you can do is implement a firewall rule. So I could just go IP firewall, add a filter rule. And what you need to understand, there's a difference between forward and input. If the traffic was just going to the router's address or IP, it would be an input chain. If we're forwarding, so let's say we're sending that traffic back to the switch, so it goes to whatever host, then we are going to set the chain as forward. So let's say I do not want 172.16.0.0/25 when it's connecting to 192.168.0.0/24. Let's say we just want to not allow ping. So we're going to set ICMP. And then what I could do is tell it to drop it. So I'll apply that. Now let's navigate back to that window for the phone PC. And let's see, can I still ping 192.168.0.254? No, I cannot. So this type of VLAN usage with the VLAN interfaces, we can now actually implement stuff like the firewall rules for it. And we can basically have access control and say how we want traffic to move across the network. All right, so that is now just basic inter-VLAN routing. Let's quickly do something fun. We're going to now set up a VLAN link between a provider edge, which is an ISP router now, and the CPE so that we can get internet breakout. So I'm just going to get onto Winbox again. Let me just open up a new Wine terminal. So CD to downloads, Wine Winbox. And I'm just going to connect onto my provider edge because I am an ISP engineer and I've been asked to set up a layer 2 link from the provider edge to the CPE. So let's just look at our neighbors, connect onto it. So now I'm on the provider edge. There we can see the PE. And we're first just going to set up normal VLANs between our networks. So let's just increase this size. Actually, it's already max size. So all I'm going to do is same thing. I'm going to add a VLAN interface, but I'm going to tag it on Ether2. So VLAN, and let's call this customer whoever VLAN 559. I think I made that. Let's just check. 559. Okay. So VLAN 559, and I'll tag it on Ether2. And similarly, I'm going to go into the CPE, which is the customer presence equipment. And let's just add another VLAN interface. Call this to ISP VLAN 559. My VLAN ID is 559. And I am adding that to Ether1, which is the uplink to the ISP network. Now we've basically got a VLAN. Let's actually see if I could do this, because this looks a bit better. There we go. So left side is our CPE, right side is our PE. Now let's just add a very basic IP address between these two routers. So on my custom or my provider edge, I might add 10.0.0.1/30. Add it to that VLAN. And for the CPE, I'll do a similar thing, 10.0.0.2/30, and add it to my 2ISP VLAN 559. Now what this has in essence done is I can now from the CPE ping 10.0.0.1. Let me just try and maximize that, because that doesn't look right. There we go. We can see it is actually able to ping and get a response. And what this allows us to do is now we can actually route traffic through the ISP network to get internet breakout, which is awesome. Because what I'm going to do is I'm just going to treat the CPE almost as a normal client device. So let's just set up some NAT rules quickly. Let's just say any traffic going out of the VLAN interface, we're just going to masquerade so that the traffic gets masked as the 10.0.0.2 address. And this is actually so cool. And then all we're going to do is if I ping out now from a PC, let's say this VPC, it's down here. I actually think I've got it open somewhere. Actually, we can just do this from the phone network. So let's keep a ping running to 8.8.8.8. And there we can see we are pinging, but we're getting an issue. But the issue right now is that the PE doesn't have any type of natting set up. So let's just do that as well. I'll log on to the PE. I'll add a NAT rule out to the intranet now. And let's just say anything that is going out of Ether1, we're just going to mask. And this is just a quick, dirty way to do this. You might want to set up some additional source-based NAT and apply it to a specific IP, but this is just for demonstration purposes now. So what is going to happen in theory is this CPE will now NAT all of its traffic out to the provider edge on this IP on the VLAN that we've configured, and then the provider edge is just NATing it out to the internet, and we should have internet access. So let's go back to that VPC, run a ping, and I'm getting an error still from the MikroTik. Let's just quickly see on the MikroTik if we've... Oh, I actually know what's wrong. So on the MikroTik, we haven't actually set up any routing here. So that's the provider edge. Let me just go back to the CPE. So let's just add a default route out to the internet to say if we want to go to the internet, use 10.0.0.1 as the gateway. So now if I ping out, we should actually have success. Let's do our ping, and there we go. We can see I've actually got internet breakout. And this is a very good example of a customer's LAN now connecting to a CPE, and the CPE is being brought into our ISP network on a VLAN, and now we're able to provide them internet access. And this is just being done with some basic NATing and routing, but we'll get more into routing in the next videos where we're going to be going deep into routing. But I just wanted to show you how you can get this to work quickly. Besides the intra-VLAN routing and what we just set up with a basic VLAN, let's do the QnQ as well so that you can see QnQ in action. So let's say on that provider edge and even on the CPE, let's say you wanted to separate the voice and data traffic. You wanted to have special queues bound to a specific interface so that you could rate limit. Let's say you're providing the customer with a 10 meg service and you want to assign 9 meg to the data and 1 meg to the voice. Then you could very easily achieve this with a bit of QnQ. And what we will do in this scenario is we will just create additional VLAN interfaces. And let's call this customer whoever data. And then I can assign my VLAN ID, and this I can make whatever I want. It's going to be hidden inside the initial 802.1 tag. So I might make this VLAN 100, and I will put it or tag it against the VLAN interface, and I'll apply that. And I'll just copy the same thing. But instead of data, we make this voice. Put the VLAN ID as 200. And I apply that. And now we've got QnQ configured on the provider edge. Let's also just quickly add some IP addresses on them so we can confirm that it works. So I'll move this IP address on the actual data interface now. And let's just add a new IP 10.0.0. Let's make it 5/30. Let's put that on the voice sub VLAN. Now I just need to configure the QnQ on the CPE. So I'm going to go into my interfaces. I'm going to add new VLAN interface. Let's call this data. Make it a VLAN ID. This still needs to match, but now my interface is the 2ISP VL559. Let's copy the data, call it voice, make it 200. And maybe let's just make it nice. Call it like WAN voice or something so that you are aware this is going to the outside world. But that is more of a preferential best practice type of thing. So now we've got QnQ VLANs. Let's also just move that IP of 10.0.0.2 to the data queued VLAN. And let's make .6 the voice WAN. And then what I'd like to see is if we can actually ping across these QnQ interfaces. So let's test that from the CPE quickly. Can I still ping 10.0.0.1? I can, and that's over QnQ. And can I ping 10.0.0.5? And I can ping that as well. So this has now allowed me to create two sub VLANs on a WAN scale. And now you can apply stuff like queues to each of those sub interfaces instead of just binding it to the one big 2ISP VLAN 559. All right, so that actually covers QnQ as well. So you've now seen how to set up QnQ. You've seen how to configure basic VLANs. You've seen intra-VLAN routing and some VLAN theory. I'm going to end off the video here. I'd like to thank you guys for watching, and I'll catch you in the next video. See ya.